Alright, now on to part 2. And part 2, we're going to focus on what we call the second derivative test. So what we were just doing was not the second derivative test. We were using the second derivative to find inflection points. Now the second derivative test is another way to find maximums and minimums, but using the second derivative instead of the first derivative test. So this again is on your sheet, this theorem, but if we let f be a function such that the derivative at c equals 0, and the second derivative of f exists on an open interval containing c, if the second derivative of c is greater than 0, then f has a relative minimum at the point c, f of c. If the second derivative at c is less than 0, then f has a relative maximum at c, f of c. If the second derivative at c is 0, then the test fails, and so we have to use the first derivative test to find out if it's a maximum or minimum or neither. So this should make sense because the second derivative is telling us, is it concave up or is it concave down? And if something is concave up, then that point is going to be a minimum if it's a critical value from the first derivative, if the first derivative equals 0 there. If the second derivative is concave down, or I'm sorry, if the second derivative is negative, then the function is concave down, which would lead us to having a maximum. Okay, so let's do an example. Alright, so first let's find the first derivative. We need to find the critical values. So f prime of x is negative 15 x to the fourth plus 15 x squared. Now we want to find our critical value, so we're going to set this equal to 0. And I'm going to factor out a negative 15x squared. So I'm going to be left with x squared minus 1. And so now if I set each one of these equal to 0, so I factored x squared minus 1 into x plus 1 and x minus 1. That's where the x plus 1 equals 0 and x minus 1 equals 0 come from. So I get x equals 0, x equals negative 1, and x equals 1. So those are my critical values. Now let's find the second derivative. So the second derivative is, let's see, this is my first derivative, so negative 60 x cubed plus 30x. So now the second derivative test tells us to plug in our critical values from the first derivative and see what we get. So f double prime of 0 is 0. So this tells us we have to use our increasing and decreasing chart from the first derivative because the test failed since we got 0. F double prime of 1 is negative 30. So that's negative. So if this is negative, that tells us that it is concave down, which means that it is a maximum. And then f double prime of negative 1 is positive 30. So this is positive, so that tells us it's concave up, which tells us it is a minimum. Alright, so now, because we failed at 0, we're going to do our first derivative test now, but only for 0. So if this is 0, then now I have to be careful. Since 1 and negative 1 were other critical numbers, I need to use values between 0 and negative 1 and between 0 and 1. So I'm going to use negative 1/2, and I'm going to use 1/2. So then I know f prime of negative 1/2. This comes out to be 2.8125. And f prime of 1/2 is the same thing, 2.8125. So those are both positive. Therefore, at 0, it is neither a maximum or a minimum because there was no sign change. So now we can answer our problem using derivative speak. So we can say, since f prime of 1 equals 0 and f double prime of 1 is negative at 1, 2 is a relative max. And the 2 comes from f of 1 is 2, f of negative 1 is negative 2. And so then we do the other one. Since f prime of negative 1 is 0 and f double prime of negative 1 is positive, at negative 1, negative 2 is a relative min. So those are our answers. Alright, next one. I want you to try this on your own. So if you're given f of x equals x to the fourth minus 4x cubed, use the second derivative test if possible to find relative maximums or minimums, and I also want you to find inflection points. So pause the video, unpause when you're ready to check your work. Okay, so for this one we come up with two inflection points. One is at the point 0, 0, the other is at the point 2, negative 16. And we come up with a relative minimum at the point 3, negative 27. So now let's look at all the work to see how we got that if you are confused. So first, find the first derivative. F prime of x is 4x cubed minus 12x squared. Use that to find the critical values. So I set that equal to 0. I factored out a 4x squared. Set each factor equal to 0. I get x equals 0 and x equals 3 are my critical values. Again, notice how I'm making sure to emphasize, circle and label your critical values. Keep your work organized. Now I'm going to do the second derivative test. So first find the second derivative. The second derivative is 12x squared minus 24x. Plug in my critical values to the second derivative. F double prime of 0 is 0. So for that one, the second derivative test failed, which means that I have to go to the first derivative test. So I made my chart, my increasing decreasing chart. So I used 0, I plugged in negative 1 and 1 into the first derivative, and both of those came up negative. So therefore at 0 it is not a minimum or a maximum. Okay, back to the second derivative test. F double prime of 3 is 36. Since that's positive, remember I don't care that it's 36, I just care that it's positive. Since it's positive, that tells me that it is a relative minimum because it's concave up. So using my derivative speak, since f prime of 3 is 0 and f double prime of 3 is positive, at 3, negative 27 is a relative minimum. Alright, great. Now let's move on to points of inflection. So I need to find my possible points of inflection, which come from setting the second derivative equal to 0. And I factored out a 12x. So I get 12x equals 0 and x minus 2 equals 0. So I get x equals 0 and x equals 2 are my possible points of inflection. Again, circle it, label what it is, keep your work organized. Now for inflection points, I have to use my increasing and decreasing chart for the second derivative. So I make my chart, put in my possible points of inflection. I used negative 1, 1, and 3 for the second derivative. So f double prime of negative 1 is positive, f double prime of 1 is negative, f double prime of 3 is positive. So I put those in, positive, negative, positive, and now I see that I have an inflection point at 0 and an inflection point at 2. So using my wonderful derivative speak again, since f double prime of x is greater than 0 on negative infinity to 0, and f double prime of x is less than 0 on 0 to 2, at 0, 0 is a point of inflection. Since f double prime of x is less than 0 on 0 to 2, and f double prime of x is greater than 0 on 2 to infinity, at 2, negative 16 is a point of inflection. Okay, so in conclusion, inflection points are where concavity changes. The second derivative test allows us to determine maximums or minimums through the use of concavity. And then remember, the mean value theorem is just basically an extension of Rolle's theorem. One thing to point out, so the second derivative test, you might be asking yourself, well, why do I even need to use that if I have the first derivative test? And to be honest, you don't. But sometimes it's easier or quicker to use the second derivative test than the first derivative test, or vice versa. As we've seen, the second derivative test doesn't always work because you might get 0. So in that case, it won't work. But it is another option. Yes, on a test or a quiz, there will be times where I will make you use the second derivative test, but for the most part, if you're just asked to find maximums and minimums, it's really up to you whether you want to use the second derivative test or your increasing and decreasing chart from the first derivative. Either way works. That is the end of our video. Enjoy the rest of your evening.